Hello, Leetcoders. This is the Polyglot programmer, also known as Josh or João, whatever you want to call it. Today, I want to go through this problem, which is quite an easy problem once you learn it, like anything else, right? So usually this problem can come wrapped around other problems. It can come inside a different problem. Sometimes the interviewer can just come to you and ask you, hey, let's say that you get a ordered list. How would you go about finding a number in an ordered list? Or maybe you get an unordered list and you want to find a number. This would still be an option, although you would have to sort the list first, and then you would increase your time complexity there. But and sometimes the interviewer may just ask you, hey, so what's the optimal way to find a number in the order list? That's also something that you might have to deal with. So the problem that I'm talking about is the binary search. So here's what it says. So given a sorted in ascending order integer or array of numbers in a target, write a function to search the target in nums. If the target exists, return its index. Otherwise, return -1. So, so here's an example, right? So here's an example. So you have a list of -1, 0, 3, 5, 9, 12. And you want to find 9. Right, so of course, one option would be, oh, let's just iterate through the entire list and just compare whatever is on the current index with that number and see if it's true. If it's true, just return the index. But that doesn't really give you a very optimal solution. That would give you O of n in worst case, because your number might be in the last place. So you don't really want to do that. So what binary search does is that you get a list and you're going to look in the number that is right in the middle. So here you would look at, let's say, 3. And then you say, hey, is 3 higher or lower than 9, which is our target? Oh, 3 is lower. So that means that 9 is definitely not below 3. So you throw all this away and you get this guys now. And then you get the number that is in the middle of this list, and which is 9. And then here you would and then here you would return the index of 9. So, and why is this optimal? Because for every iteration you're basically only looking at half the list. So if you start with 100 items, then you're going to look at 50 and then 25 and then 12 and then 6 and so on. So you cut by half your list every time. And that gives you a time complexity of O log n and a space complexity of 1 constant. So you don't, because you don't use any other space to do this, right? And the way I learned to do this is by, so we first declare pointers, a left and a right, pointing to each edge. Then you iterate over your array while left is less or right. And here you get the middle element. You compare values. So here if it is equal, you return. If it's less than the target, then you move the left pointer to middle was plus 1. So you basically have this list here, right? So middle is less than 9. So you're going to get the left pointer, which was here in 1, and you're going to move to whatever is right of 3, right? And you do the opposite for, for the right. So if the middle is higher than the target, so it feels the opposite. Let's say that our target is -1. So you check 3, but 3 is higher than this guy. So you're going to get the right pointer, which is pointing to 12, and you're going to point now to 0. So it's 3 minus this guy. And that's it. And at the end here, you return -1 because that's what it says here. If you can't, if target exists, then return index, otherwise return -1. So let's do this. This is quite easy. So first we declare left and right. -1, right? Left less or equal than right. Less or equal, you don't want just less, you want less or equal because there may be a point where your target is exactly on the last position that you're going to compare. So if it's just left less than right, there's always going to be one element that you're not going to check. So you don't want that. So here we get the middle. So let's get the middle. So middle is equals left plus right divided by 2. So you're getting whatever index is left, whatever index is right, you sum them and you divide it by 2, because then you get whatever is in the middle, right? Yeah, so let's say that you have here 10, you have left at 0, right at 10, then that you get 10 divided by 2, 0 equals 5, right? Yeah, and then here you compare. So f middle target return middle. So then you return the index. Now f nums middle less than target. So if middle is less than target, so that means that target is here, then we're gonna move left because this one. L left nums middle are good. Then we move right. -1. Return -1 if nothing goes right. So let's run this guy. Hopefully I didn't do any typos. Okay, accepted. All right, that's good. Use faster than 87%. Use less memory than 79%. It's not horrible. It's good. So this is it. This is binary search, guys. Feel free to ask any questions in the comments. And see you in the next one.